Okay, we are live.
Hi, everyone. Welcome to episode 6 of Wikimedia Tech Talks 2020. I'm Alex, and I'll be your host today, standing in for Sarah R. We have an awesome talk today, and before we get started, I want to note that I'll be monitoring questions during the talk, both here in YouTube and on IRC in the Wikimedia-Office channel. So if you have questions during the talk, feel free to post them there, and I will ask them at the end. So let's go ahead and get started. Today we have Subbu Shastri, and he is a principal software engineer at the Wikimedia Foundation and the manager of the Parsing Team. Today he'll be talking to us about retargeting extensions to work with Parsoid. Take it away, Subbu.
Thank you, Alex, and thanks, Brendan, for all the support. Good morning, good afternoon, good evening, wherever you are, and thanks for coming for this talk. As Alex said, my name is Subbu, and I lead the parsing team here at the Wikimedia Foundation. And today I'm going to talk about how to retarget your extensions for Parsoid. Before that, let's look at a little bit of background. As many of you probably know, there are two parsers right now that deal with wikitext in MediaWiki. There is the core parser for MediaWiki that's been the default since about 2003. And it serves all read views on desktop and mobile web, and it also backs the Action API. So this parser can convert wikitext to HTML, but cannot convert the other way around. So as part of the visual editor project in 2012, we developed Parsoid so that we could not only convert wikitext to HTML, but could also convert HTML that was edited in Visual Editor back to wikitext. And this is one of the distinguishing features of Parsoid. In addition, the output that Parsoid generates for the wikitext is semantic HTML. The markup has information that lets clients infer information about wikitext without having to do any wikitext analysis themselves. So it's expanded from being used by Visual Editor to a lot of other clients since then. Content translation, Flow, KVix Offline Reader, Google, they all use the output of Parsoid. Most recently, Discussion Tools, a project that was launched, also uses Parsoid. So one thing to note was that this Parsoid was written in JavaScript using the Node.js framework. And this was the case till about 2019 and 2018. So last year, we ported JavaScript, the JavaScript version to PHP. And this has been now live in production for all Wikimedia wikis. And as of MediaWiki 1.35, this is going to be the default install of Parsoid of MediaWiki. So given that we have two parsers, and given that the core parser cannot really support the clients of Parsoid, and given that Parsoid's annotated HTML provides more information, it's only natural that we want to consolidate behind Parsoid. And it really doesn't make sense to maintain two parsers in the long run. So one of the goals of the parsing team over the last few years is to make Parsoid the default wikitext engine for MediaWiki. And as a first step, we want to start transitioning this on the Wikimedia cluster sometime next year, probably late 2021. So what does this mean for extensions? The bad news is that all extensions that use parser hooks or the Parser API will need to be updated. The good news is that most extensions probably will be very minimally affected. We are trying to make this transition as smooth as possible and not need extensive rewrites. Specifically, if you have an extension that has a parser hook listener or uses any of the public methods or properties of parser.php, then your extension will need to be updated for Parsoid. Given that for next year, we are only planning to transition the Wikimedia wikis, this also means that we only initially care about extensions that are deployed on Wikimedia wikis. We, of course, are interested in wikis, so extensions in general, not just those on the Wikimedia cluster. But you have a little more time to play with this and give us feedback, and we definitely will evolve the extension API as required to make sure all the use cases are met. So let's first look at why I mean, just because we move from the core parser to Parsoid, why would you need to transition your extension as well? What are the differences that cause this? So first of all, the core parser hooks refer to very specific parsing stages. So for example, here is a list of some hooks. And as you can see with the before and after qualifiers, they reference very specific parsing stages in the pipeline. But Parsoid does not have the same pipeline stages at all. It has very different pipeline stages. In fact, it has about 40 odd passes, some that run on tokens and some that run on the DOM. And even this pipeline is not static. It keeps changing over time. Just over the last 6 months, we've added passes, we've removed passes, we've merged some passes, we've reorganized the order of the pipeline. And so it really does not make sense for us to expose the details of this pipeline to extensions. So that's a pretty significant difference between the core parser and Parsoid. So we really cannot support the same hooks in the same format when they refer to very specific pipeline stages in the core parser. Secondly, the core parser exposes sequential processing of wikitext. That is, it always processes things in sequence. But Parsoid does not expose the processing order. So as I mentioned, till very recently, Parsoid was implemented in JavaScript and using the Node.js framework. And it had a lot of out-of-order async processing. What this means is that if you had the same extension tag used twice on the page, it was not guaranteed that they would be called in the same order. They could be called in different order. And secondly, while this has been disabled now, Parsoid also, as a performance optimization, used to reuse content from a previous parse. So what this means is when that content is reused and this content came from an extension, this means that your extension will not be invoked on that content. So what together this means is that Parsoid will not and cannot expose the specific processing order. This also has implications for extensions. Thirdly, the core parser treats everything as strings, whereas Parsoid treats extension output as documents. This is mostly a minor change. So instead of dealing with HTML strings, you deal with DOM documents. And hopefully, it'll actually make things easier. And lastly, the core parser exposes its methods and objects directly, which is why you have a lot of extensions using whatever method they wanted to use and could use. Whereas Parser prefers keeping the implementation details opaque and will only provide an API object to extensions. You won't get a parser object in your extensions. So what does all this mean then? Given that there are very different pipeline stages, and given that Parsoid does not expose them, as it turns out, we actually have far fewer hooks than the core parser. And secondly, even the hooks that are exposed are not event hooks. They are not parsing event hooks. They are more transformation hooks. That is, you need to think about what you need to transform, not about when you need to transform something. And secondly, the fact that Parsoid does not guarantee processing order means you cannot maintain global ordered state in your extension implementation. For example, counters. You won't be able to maintain counters reliably in your extension. Thirdly, there is no direct access to the parser object, but you'll get a parser API object, and hopefully this will give you all the functionality that you will need to work with wikitext. So for today's talk, I'm going to focus only on tag extensions. Parsoid does support content handler extensions, and we'll add this information to the wiki. But for today, I'm just only going to look at tag extensions, that is, those that implement a specific extension tag. And secondly, given that Parsoid can convert wikitext to HTML and HTML back to wikitext, we also support hooks that let you change how you convert HTML to wikitext. But for today, I'm only focusing on the wikitext to HTML conversions because all the extensions that exist today will only be doing this particular format, and we're only concerned about the transition from core parser to Parsoid. But if you have an extension that you want to handle the HTML to wikitext conversion, then get in touch with us and we'll give you any advice or can work with you. So let's look at an overview of tag extensions. So here is a bird's eye view of the Parsoid wikitext to HTML pipeline. And here I've only looked at parsing stages that are relevant to extensions. So as the black box shows, you have wikitext coming in and out you get HTML. And inside you have a whole bunch of stages. And the very first stage is where your wikitext is tokenized into tokens. And one of these tokens will be extension tokens. And at some point in the pipeline, the extension handler inspects these tokens. And based on the listeners that have been registered, it will invoke your extension and pass it the extension source, the extension arguments, and API object for interfacing with the parser. And the extension is expected to return a DOM fragment. Note that this is not an HTML string. This is a DOM fragment. This is one of the changes also that I mentioned earlier. So this DOM fragment then goes through the pipeline, and at some point, it's unpacked. When I say unpacked, what happens is the DOM fragment is basically tunneled from the point that you return till this pipeline stage. It does not get modified. And at this point in the pipeline, it's expanded into the full page DOM. And so wherever an extension tag existed, your DOM is put in place. And further down the pipeline, at this point, it's a DOM. The whole page DOM. This DOM is then passed to extension DOM processors. Here, your extension processor will be given the full page DOM, and once again, the same API object. And is expected that you'll probably modify the page DOM in place. So as the picture showed, there are very clearly there are two places where extension hook into the pipeline. One is a localized transformation hook, where you take the extension source, extension arguments, and return a DOM fragment. And the other is a global DOM processing hook, where you get the entire page DOM and you modify the DOM. And what's not shown in the diagram is a wikitext linting hook. This is only relevant if your extension handles wikitext and you care to lint the wikitext. And maybe there will be others in the future, depending on the use case. But as of today, there are just these three hooks that extensions have. And once your extension returns the DOM, Parsoid annotates your DOM with additional attributes. This is a type of on data MW attribute. The type of tells clients what kind of output it is. In this case, for example, if it's a poem extension, it gets the annotation MW:extension/poem. So ref tags will get MW:extension/ref and so on. And the data MW attribute has information about the extension arguments. So this information is what clients can use to determine when a piece of the page came from an extension, and specifically which extension and what arguments were used and so on. And the other part to note is that the DOM that your extension returns is tunneled through the pipeline automatically. So what this means is that in place of your DOM, we take a placeholder node that participates in things like paragraph wrapping, list handling, and so on. But the actual DOM is unmodified by intervening passes. So this is very similar to the strip state mechanism that extensions currently use to explicitly manage this process. So in Parsoid, you don't need to do anything special. Parsoid takes care of this for you, for all extensions. So let's step back a little and see how extensions actually register your handlers. So we're using the same extension.json mechanism that you're familiar with. We just add an additional property called Parsoid modules for config. And you have one of two options. You can specify the config inline. It's a JSON config. Alternatively, you can provide an object factory declaration that provides an implementation of the extension module interface. This interface is exactly one method, getConfig, which would return the configuration for your extension Parsoid listeners. So let's look at an example. So this is an example for the Cite extension. This is something that's currently in production. It's been in production for a long time. So it declares the name of the extension Cite, and it lists a bunch of tags that the extension declares. So there are two array entries, one for ref, the other for references. So you have a name, which is a ref, and you specify a handler. This handler, in here I've inlined the name of the class, but what we care here is it can also be an object factory declaration again. and it's expected to return an implementation of the extension tag handler class. Besides this, besides the tags, you can also declare the global DOM processors, which I mentioned earlier. This is an array. You can declare more than one DOM processors if you so choose. And this should extend the DOM processor class. We'll take a look at these classes further down in the talk. But this is how a config looks like. Should be fairly straightforward. So the extension tag handler is an abstract class which declares currently 3 transformation hooks with some dummy implementations: source to DOM, DOM to wikitext, and a lint handler. For this talk, we're only going to look at the source to DOM, which takes your extension source and converts to DOM. And it's given the signatures. You get an extension API object, you get the extension source and the array of arguments, and you return a DOM. At the very least, we expect that extensions will implement this method. Otherwise, I mean, why are you even writing this extension, right? I mean, you'd probably implement this. And DOM to wikitext is optional. And if you don't implement this, Parsoid takes care of handling this automatically for you and converts the HTML back to wikitext on your behalf. And here is a very high-level overview of how a source to DOM method might look like. And this is I'm only mentioning this here in case your extension handles wikitext. So at some point, you'll probably end up with wikitext in your extension. And if you need to convert this wikitext to DOM, then you'll go with the extension API object. And this extension API object takes your wikitext and spawns an entirely new Parsoid pipeline. To reiterate, note that it's an entirely fresh pipeline, which means that it is parsed as if it's a top-level document. It's completely processed. There is no notion of partial processing. There is no notion of only selective passes. So it's the entire pipeline. But you do get some semantic control over the pipeline. For example, given that this extension is used on a page, you might have constraints on how this particular output is embedded. For example, if it's an inline, it's used in inline context or a block context. Parsoid can enforce certain constraints on how the output looks. In the future, we may add additional output types or embedding contexts, but for now, it's only inline or block. And as I mentioned just now, the output DOM has all the applicable passes run. And for certain optimization reasons, if there are passes that can only be run on the top-level page DOM, those are skipped right now. So the underlying principle behind this, the fact that we take your extension wikitext and completely parse it, is because we believe that wikitext should behave uniformly no matter where it shows up, whether it's in messages, whether it's in extensions, templates, no matter what. It makes for a lot more sensible wikitext handling and easier to reason with wikitext. And any deviations you find, any deviations from that particular behavior should have some conceptual grounding. So for example, the one deviation we support is by letting you specify the output type or the embedding context type. For example, if your extension is going to be used in a CSS context or HTML attribute context or inline phrasing, inline or block context, and so on, then it makes sense you want that particular embedding context to be handled for you. Right now, as I mentioned, it's only inline versus block, but in the future, perhaps we might add all these other types for extensions and pretty much other contexts as well, like templates and messages and so on. So let's look at what the Parser extension API supports. Broadly, there are the API methods can be categorized into the following. Obviously, if you need to deal with wikitext, then there are methods to let you convert wikitext to DOM. There are a bunch of flavors of this. We'll go over this. And there are also methods that help you convert DOM to wikitext. Secondly, you might want to convert HTML strings to DOM or DOM to HTML strings. And I'm highlighting this for one reason, because you don't need to necessarily use the methods by the API. You might think you could use the native DOM or library methods, because I mean, HTML is standard, right? You can convert HTML to DOM, DOM to HTML using any library that's compliant. The reason we provide these API methods is because Parsoid maintains the DOM in a particular canonical form, and we strongly encourage you to use these methods because these methods are aware of the canonical representation and make sure everything works properly. And in case you use native methods, there might be occasions for subtle bugs down the line. So that's the reason we've provided these HTML to DOM and DOM to HTML methods. And we encourage that you use these methods in all your extensions. And obviously, there are methods that deal with extension args. For example, if you want to update an argument or inspect something or modify or delete, whatever it may be. And there are methods to get properties of the page. For example, the page title, the page URI. You can get the configuration of the wiki. You can get configuration of the page. Potentially, your extension may inspect these configurations and do something different based on what is how the wiki or the page is configured. And lastly, you can query properties over the extension tag itself. For example, is it a self-close tag or whatever it is? I forget all the methods there are, but there are a bunch of methods that you can inspect. And there are a few other methods. Some are probably transitional and may go away. And of course, depending on what we discover, we may add additional methods. So let's look at a few examples. So before we look at the examples, it's useful to broadly look at what kind of extensions in terms of what they do with wikitext, how they handle wikitext. So there are certain extensions which don't deal with wikitext at all. They don't wrap wikitext. For example, NoWiki, the pre extension, the syntax highlight extension, or the raw HTML extension. They just take some extension source and generate HTML, or in our case, a DOM. So conceptually, it's just your input is converted to an output where your conversion generates a DOM. Alternatively, you might have extensions like ref, which is just a thin wrapper over wikitext. I mean, it's all of the content of ref tag is wikitext. So in this case, it's still a transformation from input to output, but the transformation is where you parse the wikitext. Thirdly, you may have extensions like poem, where the content is more or less wikitext, but it has some special semantics. And so given that Parsoid does not support special semantics, if you need to support the special semantics, the extension will have to do that yourself. So you take your input, which is more or less wikitext, and mangle it to make it wikitext. And then you pass this canonical wikitext to the parse wikitext API method that the API provides you. You get a DOM, you then post-process the DOM based on the fact that you had mangled the input, and then you get the output. Or you have extensions like gallery, where you have a whole bunch of snippets. Individually, they are wikitext snippets. And once again, they may have special semantics. For example, in gallery, the image markup is not canonical wikitext syntax. The square opening and closing brackets are left out. So once again, you mangle the fragment of wikitext, and you get canonical wikitext, and then you parse the wikitext, and you build a DOM based on the DOM fragments you get for each other fragment. So the reason I highlight this is based on which category your extension belongs in. You might use a different set of methods from the API when you deal with wikitext. It's just a useful guide. It's not something to be taken as solid advice, but it's potentially useful when you look at your extension and think about how you might use the API. So here is an example of the raw HTML extension. This slide is the entirety of the implementation. In this case, the extension provides the config inline, so which is where it declares that it implements the extension module interface. So config returns an array where it declares a single tag, the raw HTML, and declares that the handler is the class itself. Given that it implements an extension tag handler, so it extends the extension tag handler abstract class and provides a sourceToDom method. The signature we already talked about before, and the implementation is fairly straightforward. It takes the source, which is basically an HTML string, and uses the API to convert HTML to DOM, as per recommendation that I mentioned earlier. So it converts HTML to DOM and returns a DOM. That's it, nothing more. Now let's look at a slightly more involved example, the pre tag. I'm skipping the config here, But in this case, a pre-tag, again, all it does is it takes the content of the extension and wraps it with a pre-HTML tag. So in this case, you create an empty DOM, you create a pre-element, and further down the line in over here, let's see if I can do this. So you create the DOM here, you create the pre-tag, and over here you're appending some content to the pre-element, which is what you're supposed to do. In between, over here, you sanitize the arguments, and you do some processing of the text. If there are no wikis, you strip the no wikis, you trim some lines, decode the wikitext entities, and that's it. And one thing I'd like to highlight here, which is this, the use of DOM compat. The reason this exists is because the libxml DOM library is not entirely spec compliant with respect to DOM version 2. And therefore, in Parsoid, we've built a compatibility layer, which makes the make sure that the implementation is spec compliant. So we recommend that we use the DOM compat method instead of using libxml directly. If you want more details, you can go to this particular fab task and look at why that's the case. But that's a minor tangent, but broadly, pre is fairly straightforward. You create a DOM, you process the text, and add the text to a pre-tag and return the DOM. That's it. So those two are fairly simple. Let's look at a more involved example, a ref tag. You might all know what a ref tag does, but it's useful to go over an example because it's helpful in looking at the implementation. So here is a simple sample wikitext. This is a single ref tag, which, as we said earlier, it wraps some wikitext. In this case, it uses some italics and bold of some content. And in the end, the references section over here is where you get the references. So this is how the rendered output looks like. So as you see, where the ref tag showed up in the source right after the foo text, you get a link, a numbered link, which points to the references section at the end of the document. And that's where you see the content of your ref tag. So essentially, the content is not at the place where the ref tag showed up. So this is useful when we talk about implementation in the following slides. Let's first look at the source-to-DOM implementation. So as we said, this is an extension that wraps wikitext. So it does nothing more. So the implementation is pretty much straightforward. This is all there is. I've skipped some of these checks here, which is to figure out whether you want to allow nested refs. This is not important for the talk. I'm going to skip that. But besides that, essentially all you're doing is asking the API to convert the extension tag to a DOM. And since a ref tag wraps its output in a souped HTML tag, you pass the option where you ask that the wrapper tag be a soup. And given that it's used in inline context, you say that the context is inline, which means no paragraphs and no indent pre. And that's about it. That's all the ref tag does. It asks the API to convert it to DOM and returns a DOM. Now you say, wait a minute, right? That handler returned the DOM of the ref's content. How does this content now migrate to the references section? And what happened to the numbered reference link that we saw earlier, right? So let's look at the pipeline once again. So the ref source to DOM is the hook that is early in the pipeline. This is a local transformation hook. All it has is local information. It just has the extension source and the arguments. It does not have access to the final DOM. So even if it could move the content to the DOM, it would not be able to move it. And secondly, as we mentioned earlier, extensions cannot maintain count of Parsoid's processing model. So the ref source to DOM cannot do this work. So if you look at the Cite config from before, besides the ref class handler, which we just looked at, it also declares a DOM processor, which is implemented by the ref processor class, which implements a global DOM processing hook. So that is where you have, so this is the hook that's marked in red. That's a ref processor. It's invoked much further in the pipeline when it has access to the entire page DOM. So let's see what it does. So one thing to know is, given that Parsoid adds extension output to the DOM, the page DOM is your global state object. So that's how you maintain global state effectively. I mean, you cannot maintain state within your extension as long as you return the relevant output in your source to DOM that you can extracted input, extracted information in your global DOM processor. So what does the ref processor do? Given that it has access to output of all ref tags, it walks the tree in order and harvests all the ref content. It generates the references section in the required format, whatever the tags it needs to generate. And it migrates the SUP content from where it showed up to the references section and updates the SUP at the ref sites with links to the references section. Since it walks the tree in order, you can actually now start counting and associating ref tags with the specific order in which it showed up in the page. So what this is doing is effectively restructuring the DOM. So this is how you maintain counters. You do some preliminary work in your source to DOM local hook. And when you get to the global hook, you restructure the DOM based on what you need to do. So stepping back to look at the DOM processor class. So it currently declares provides two methods. One is the wikitext post process, which is used in the wikitext to HTML direction. And then there is the HTML pre-process, which is used in the other direction when you want to convert DOM to wikitext. Right now, this is not hooked up in Parsoid, but is something that will be available in the future. But let's look at the wikitext post process. This is invoked by Parsoid when the full page is constructed. It's almost at the end when most, but not, the caveat is that not all information is present in the DOM. So stuff like media information, for example, things like audio, video, or image information might be missing in the page. Link annotations like whether it's an external tag or whether it's a red tag or a disambiguation link might not be present. Language converter has not run on the page yet. Heading IDs may not be present, and section wrapping has not run. So if your extension needs information that is not present at this point, then we may potentially have to introduce a new hook. So far, we've not found a need for this, so we've not added this. But in case your extension does this work, then let us know. Then maybe we can add one more hook called a finalize doc, which is invoked right at the very end. So far, we've looked at some examples. We've looked at what hooks Parsoid represents and what the API supports and how you would piece those all together to implement your extension in Parsoid. But if you already have an extension that works with the core parser, how would you map that functionality between the core parser and Parsoid? Let's take a look at that now. Firstly, let's look at parser hooks. I won't go over all the parser hooks. You can find that information on the wiki, but let's look at a few. So if you have, if your extension uses the parser first call init, then you probably are using this for registering extension tags or other hooks or other listeners. You don't need to do this in Parsoid. You can declare that entirely in the JSON config inline. Alternatively, you can use you can extend the extension tag module and do that registration in the getConfig method. So you basically transfer the implementation from your parser first call init handler to the getConfig method. So if you use the parser before tidy, parser after tidy, parser after parse, then most likely you will need to use the wikitext post process DOM processor hook. And in case this is not sufficient, then as I said earlier, we can probably provide a finalized doc processor hook. This is probably the case if you use the parser after parse method and you need information that Parsoid does not provide with the wikitext post process method hook, I mean. If you use the parser clear state hook, we think this should probably not be needed because as we said, you really cannot maintain state in Parsoid reliably. So if you don't maintain state, there really is no reason that you need to clear any state at all. But if there is any reason you need to do this, let us know, and we can discuss what we can do to support this. And as we went over before, Parsoid does all the tunneling of your DOM through the pipeline stages. So you don't need to use any strip tags for doing that work. So you probably will not need the before strip and after strip handlers, but maybe you're using this for some other reason, not for actually strip tag handling. So let us know if you have use for this, and we can work with you to see what we need to introduce. So if you have hooks where you inspect limits, the parser limit hooks, then these are unaffected. So these hooks will probably be refactored into a meta parsing functionality outside the parser classes. The only difference from Parsoid land probably is going to be that instead of a parser object, you're probably going to get a Parsoid API object. That's probably the only difference. But otherwise, all the limit information that you rely on, you're going to get from those hooks. And here is one example of a hook that we do not plan to support: internal parse before links. As you might know, link syntax is heavily overloaded in wikitext. You have all kinds of, you have link trails, link prefixes, which differ between wikis. You have PST processing of links. You have so you have a lot of under other ways link syntax are overloaded, which I'm just blanking on right now. So it really does not make sense to start modifying link syntax through extensions. But if you need to modify the output of links in any way, then you should probably be able to do that using the wikitext post-process DOM hook. Alternatively, if you need to do something different with links and are just overloading the link syntax right now, you probably should use a different syntax, or alternatively use parser functions. So for example, Semantic MediaWiki uses this, and I believe it can probably use parser functions to do the same job that it is using the parser hook for right now. As I said, I'm not going over all the. Whoops, hold on. I'm not going over all the hooks here in the talk. Watch the page there on the wiki for a complete mapping. The documentation is currently incomplete, but in the coming week or two, we'll probably start updating that to add a complete mapping. The other thing that your extension might need to map is the Parser API interface. So currently the Parser API is pretty much the parser.php object. So extension probably use whatever methods that they can use that's public. So I'm not going to go over all the methods that are there in Parser, but I'm going to talk about a few methods. So the most prominent one is, if you're dealing with wikitext, you're probably using one of these 5 methods right now: parse, internal parse, start external parse, and so on, for converting your wikitext to HTML. So in Parsoid, use one of these following methods. If you need to convert your tag to DOM, like the ref tag, then use xtag to DOM. If your extension has an extension argument that behaves like wikitext, for example, gallery captions, then use the xarg to DOM. If you have wikitext that behaves like media and you need to render media, then use the render media method. For example, the gallery and image map extension use this. But if none of these 3 flavors meet your need, then use the bare bones wikitext to DOM method. So internally, this is used by the above 3 flavors that I presented there. And in the future, we may provide additional flavors based on feedback that we get. So to reiterate, you do not get control in Parsoid over how much parsing happens. For example, in the current Parser API, recursive tag parse and internal parse return quote unquote half parsed HTML, whereas others returns fully parsed HTML. So in Parsoid, there is no such notion as half parsed or full parsed. Once you give it wikitext, you get the completely parsed DOM. And once again, to reiterate, we talked about this earlier. You don't get to turn on and off pipeline stages, but you do get semantic control in the form of the output type or the embedding context, like the inline or block types. So if you have special wikitext semantics, like poem or gallery, which we went over, you would mangle the input to make sure that your wikitext has canonical syntax and canonical behavior. And then you'd use DOM processing to extract your special semantics from the manual wikitext. So this is what a poem does, or ref does. In the case of ref, the special semantics is that you migrate the content from one place of the page to another place. So that is the special semantics in the case of ref. So right now, the code in production does not expose the parser output object via the API. This is something that we know and will fix. And we also do not expose the set function hook for declaring parser functions. Once again, this is something we're going to add. And the only difference is your callbacks will not get the parser object. You'll get a ParsoidExtensionAPI. So this is a good rule of thumb. Anytime your extensions are inspecting a parser object, you'll not get the parser object. You'll get a ParsoidExtensionAPI object. And based on, as I said many times in the talk, we'll augment the method with additional functionality as we discover, either through feedback or our own exploration. Once again, watch the wiki page for complete mapping in the future. So strip markers, you probably won't need to do this, but if you have a use case, let us know. So what is the status right now? So currently, Parsoid has implemented, migrated a whole bunch of extensions already. Some have happened right from the very beginning, like Cite, for example. Cite, NoWiki, and Pre. So Cite, Poem, Gallery, NoWiki, and Pre, these implementations currently live in the Parsoid code repository, and but they strictly adhere to the API and hooks that we went over in the talk today. And these are all in production right now, which is a proof of concept that this works. And shortly in the coming weeks, we are going to migrate all the implementations from the Parsoid repository into the extension repository. So the Cite implementation from Parsoid will move to the Cite extension repository, and same for Poem. And we already have implementation of image map in Gerrit. And next in line probably will be the indicator tag we are going to tackle. And LST and translate, they are primarily skeletons in Parsoid. They're not real implementations. So we're going to rely on the language team to work on the translate extension. But of course, we'll work with them to make sure the implementation works and we provide the necessary functionality. So we also have content handler extension like JSON, which is in production as well. And there are also a couple of extensions that are used by Parser Tests, raw HTML and style tag. So all these extensions use the extension and hooks API that we went over. So it works. And so essentially, we consider this particular proposal to be in late draft stage. And as we discover unsupported, of course, independent of that, as we discover unsupported users, we'll add new hooks and update the API. And in parallel, we are also narrowing the parser.php interface. We are making more methods private, and we're deprecating a lot of things that don't need to be supported. This makes our job easier, and will also make your job easier, hopefully. And Parser Tests and CI support will land in a couple of weeks, which should make testing probably easier for you. So documents and next steps. So next steps for us is continuing outreach and soliciting feedback. We presented an early draft at Enterprise MediaWiki Con in April 2020. We solicited feedback internally in July. And this talk is next step in the process. And we are going to then send emails on Wikitech and MediaWiki and probably go through the TechCom RFC. And one thing I do want to mention is we'll do our best not to break things unnecessarily. But as I said early on in the talk, pretty much all extensions will need to be updated if you deal with parser hooks or parser API. Hopefully, in most cases, it'll be not very hard to do. The next steps for you, please learn more, dive into the details, provide feedback, and please start updating your extensions now. This is the best way to figure out what's missing, what is easy and what is hard. And this will help us migrate MediaWiki to Parsoid rendering for Wikimedia Wikis next year, and from there for MediaWiki more broadly. So please look at the code in the Parsoid repository and look at the extension interfaces. and look at some, anyway, this is all on Wiki, and you don't need to kind of stare at this slide. So there's a Wiki page, Parsoid/ExtensionAPI. Please discuss or leave questions on the talk page, because if you have any questions or discussion, it's probably going to be broadly helpful for others. And look at Parsoid's implementations for POEM, pre, Cite, etc. Look at the docs, look at the spec. And if you need to talk to us, please find us on IRC on the MediaWiki Parsoid IRC channel, or email us at parsingteam@wikimedia.org. That's it. If you have, thanks for listening, and I'm open for questions. I'm going to probably stop the screen share at this point.
Thank you, Subbu. This is really exciting stuff. So we're going to go ahead and open up the Q&A now. Just as a reminder, you can post questions in the YouTube chat or on IRC in Wikimedia Office. And we've already got a couple questions coming in, so I'm going to go ahead and start. How many extensions on WMF will need conversion?
Yeah, we haven't looked at the list of extensions, but they're I don't know. I should just say I don't know, because I can just speculate, but there's no point. We can look at how many there are, but it's pretty much any extension that uses a parser hook or a parser API.
And the next question, during the transition period, will extensions have to support both parser and Parsoid with separate code?
That's correct. You would need to, because you probably want to test your extension with Parsoid. So in that time, you want the Parsoid code, but still your extension is in production. And so you would need the core implementation as well. And this, more importantly, I think our transition strategy is that we won't do a complete all or nothing switch. It'll be a gradual process when we go wiki to wiki. So there'll be periods where some wikis are using Parsoid and other wikis are probably using the core parser. So you would probably need both implementation at the same time. And hopefully you'll probably be able to reuse code when you write your Parsoid implementation. But yes, you would need both in parallel.
And the next question, is the post-processing red links introduction also done on DOM returned by the extensions?
Yes, it is right now, because the red link is done after all the extension processes are done. So the red link will be run on your output. But as I said, I think in case your extension needs the red link information before you run your processor, then we may have to introduce a new hook. But yeah, red links will run on your output as well right now.
Is there a way to get something like the preprocessor output with Parsoid?
There are no plans right now, but if you tell us why you need it, we can talk through why you might want it or other ways of doing it, and we'll see. But right now, no, you won't get it.
And next question, it's great to see how many questions there are. We have another one. How would DOM objects be compared in PHP? Extensions such as parser functions support wikitext in the function, which I presume will be given to the function as DOM objects.
That's a good question. I think both Scribuntu and parser functions, we may have to provide some special handling for them for performance reasons, because if you have to convert tiny bits of wikitext to DOM, that probably is not relevant. So we've not completely dived into this, but I think there may be some special handling for these, which are considered core extensions pretty much. And so, but these, yeah, so that is the plan right now, to probably provide some backdoor support for them, unfortunately, unless we come up with some clever implementation techniques.
Excellent. And I have one more question. How can extension authors test their code against Parsoid?
Okay, well, I think, so I think Scott is currently working on, I should probably share I have a couple of slides for that. Let me share screen if I get this right. Hold on. Okay. So Scott is currently working on adding Parser Test and CI support for extensions. So once that is done, you'll be able to run your extension tests against Parsoid from your repository. But the more important thing is to make sure that your extensions have Parsoid output sections. And for the most part, this is only needed if your output differs significantly. So Parsoid test runner currently normalizes for certain HTML attributes like type of and about and data MW, so it doesn't compare as far as I remember. But otherwise, if your output differs in any way, then you need to add HTML Parsoid section. And Parser Test also supports multiple test modes per test. Initially, you don't need to support all these modes. You only care about the wikitext to HTML. And in case when you're testing, you know that your tests are going to fail, then you can use the known failures.json route to track unexpected failures. So if you add these failures, Parsoid will not flag your tests as failing. So here is an example. For example, in the poem extension, we've added HTML/Parsoid section to the test. In this case, the output is the same, but this is just to demonstrate, I think, how the section will look. So the HTML/PHP is the default output, and the HTML/Parsoid is the output for the test. In this case, you see that we are specifying the type of and the data MW attribute that Parsoid generates. So this is broadly how you do it. You update your Parser tests, and once the CI lands, you'll probably be able to run it in CI. Yeah.
Thanks. That was really cool. And I have another question here. Is it possible to run only a DOM post processor in an extension, for instance, to collect statistics or something?
Sure, you can. Yeah. There is no reason. I mean, yeah. Your hooks in the config, the tags array is optional. So if you just declare the DOM processors, I can just go back to the slide. So it's easier to talk through that. Right here, right? If you just skip this entire tags array, then you'll just run the DOM processors, and that's how you'll probably run it.
So for example, I could collect a count of links in the generated document.
Sure.
Cool. Excellent. Well, the questions seem to be winding down a little bit, but we'll give it a sec here to see if anything else pops up. This was really interesting. How long have you been working on this particular project?
Well, I think we've started in earnest, I think, this year by refactoring a lot of extensions and starting extracting the API from their implementation. But I think some outlines of this have been in the code for even a JavaScript version. It's just that I think this year we've started this work in earnest mostly, and to make it more formal. Yeah.
Excellent.
I see Scott is online. I just want to make sure in case you have something you want to share, or since he's also been involved in some of the work, just you want to add anything to the presentation.
I was just going to briefly mention that for those who know how French spacing works in wikitext, that's currently implemented as one of these DOM post-processor only passes. And eventually that will be a good example of a bidirectional DOM post-processor pass, where the post-processor makes some changes to the HTML, and then you're sort of responsible for undoing them when it gets serialized from HTML back to wikitext. And I think the question about parser function arguments is a good one. Currently, the existing set function hook gives you a sort of unparsed PP node object, which you can then convert to the format that you actually want. And I think that's the general idea of how that will work in Parsoid eventually as well, which hopefully will give us some space to allow you to request raw text, because some parser functions don't want parsed wiki text, or a DOM if the argument is actually a wiki text string, or in some future land where there's a a slightly incompatible wikitext 2.0 and that will smooth over the differences of what format exactly that argument was originally in. You can specifically ask in your extension implementation what format you want for your arguments. That's all I had.
Thanks. And maybe you could introduce yourself real quickly for those who don't know you.
Sorry, Scott Nanny, and also Parsing Team member.
Scott is the tech lead on the Parsing Team.
Oh, very cool. Well, thank you for joining us. Awesome. Well, it seems like we don't have any more questions. So I think unless there are questions specifically for Scott, we can go ahead and wrap things up here. Thank you so much, Subu, for this talk. This was super interesting. And thank you also to Brendan for managing the audio and video for this talk. And I just want to remind everyone to check out our other tech talks. We have some really cool stuff coming up this year. And to consider being a speaker. We're always looking for more speakers. And you can learn more about Tech Talks and get the resources from this talk on the Tech Talks page on MediaWiki.org.
Thank you, Alex. Thank you, Sarah. Brendan. And thanks, Sarah, for helping originally set this up.
Very cool.